Hello friends, today I am now going to discuss Laplace transformation. It is very important transform and it is very important topic in mathematical physics actually. So let's start the discussion about Laplace transformation. So why it is so important? Because in mathematical physics or in mathematics we all have done ordinary differential equation. So whenever we will do ordinary differential equation, we have to solve some arbitrary constant, and we have to get lots of general solution. Okay. So we have to calculate lots of arbitrary constant, and we will then get general solution in case of solving ordinary differential equation. But without calculating this constant and without calculating this lots of arbitrary constant, you can get general solution. You can solve that ordinary equation by using only Laplace transformation. So how you can use that? So let's start that discussion. So actually, what is a mathematically Laplace transformation? How mathematically Laplace transformation is defined, or mathematical definition of Laplace transformation, mathematical definition. So how can you tell that a function is Laplace transformed? If you have a function f of x such that if you do the Laplace transformation of that function L of f of x, what you will get? After doing the Laplace transformation of that function, you will get Laplace transformation of f of x equals to into the power e to the 0 to infinity e to the power minus s of x equals f of x dx, where is greater than 0. So here this is the mathematical definition of Laplace transformation. That means if you have a function f of x such that if you are doing the Laplace transformation of that function, you will get integration 0 to infinite e to the power minus sx f of x dx. So you can change Laplace transformation to Fourier transformation also. I will discuss that about also. But here what the condition for fx? Here fx should be piecewise continuous. Where piecewise continuous in finite interval. In every finite interval, fx should be piecewise continuous. So it is the Laplace transformation that if we get a function f of x that is piecewise finite continuous in every finite interval, so Laplace transformation will give us e to the power minus s of x f of x equals L of f of x, Laplace transformation of that function fx. Now suppose if we will put if s equals suppose plus minus I omega, or someone can write that plus minus j omega, where iota or j whatever, it is imaginary quantity. So you can directly turn this s of x equals e to the power plus minus iota omega x. This will be what? This will be Fourier transformation of f of x. So that's it. That's how we can change Laplace transformation into the Fourier transformation by putting s equals j omega or I omega value. That's it. So let's talk about some important properties of the Laplace transformation. The first thing of fx, the fx should satisfy another important condition, that the condition for existence of Laplace transformation will exist. Laplace transformation will exist only if limit x tends to infinite e to the power minus sx f of x equals finite value. In this condition, Laplace transformation of f of x will exist. That means if we have a function f of x such that limit x tends to infinite, e to the power minus s of x into f of x equals finite, then the Laplace transformation will exist. Some important things about Laplace transformation, that is, Laplace transformation of 1 will be what? Laplace transformation of 1 will be 1 by s. We will discuss about that. So, important properties of the Laplace transformation. Laplace transformation of e to the power ax. Laplace transformation of e to the power ax. How we will discuss that? So, Laplace transformation of e to the power ax will give us 1 by s minus a, where a is greater than a. How can we find that? Suppose let us do the Laplace transformation of e to the power minus a of x. We will get such that integration 0 to infinite e to the power minus s of x e to the power a of x dx. So we will get what? Integration, let me write clearly, integration 0 to infinite e to the power minus s minus a to x dx, okay, equals 1 by s minus a. Yeah. Another important formula about Laplace transformation is Laplace transformation of x to the power n. Laplace transformation of x to the power n. This will give us n factorial divided by s to the power n plus 1, where a is greater than 0. S to the power n plus 1, where a is greater than 0. This is the Laplace transformation of x to the power n. Let me write clearly. Laplace transformation of x to the power n will be n factorial divided by s to the power n plus a 1, s to the power n plus 1, where a is greater than 0. Okay. Another important formula about the Laplace transformation is such that Laplace transformation of cos of ax is, this will give us s divided by a square plus s square. Laplace transformation of sine of ax will be, this will give us a divided by a square plus a square. Always remember these two things. Laplace transformation of cos of ax will give us s divided by a square plus a square. Laplace transformation of sine of ax will give us a divided by a square plus a square. Yeah, that's the thing. Similarly, this is cosine, this is sine. Similarly, if we take hyperbolic function means Laplace transformation of cos of hyperbolic ax. This will give us s divided by a square minus a square. Laplace transformation of cos ax, what we are getting? From Laplace transformation of cos ax, we are getting that plus transformation of cos ax, we are getting that s divided by a square plus a square. And Laplace transformation of cos hyperbolic ax, we were getting that a square minus a square. Okay. Similarly, Laplace transformation of sine hyperbolic ax, what we will get from here? A divided by a square minus a square. Another property of the Laplace transformation is such that Laplace transformation of another property is linear property. Linear property means what? How can we relate that? Suppose we have a function f1x and another function f2 of function of x. Okay. So we are writing a superposition of that function a into f1x plus b into f2x. Then Laplace transformation of that a into f1 plus b into f2 will give us a into L of f1 plus b into L of f2. That's the thing. Laplace transformation of a from b into Laplace transformation of f2. Now let's tell about shifting property of the Laplace transformation. Shifting property. So what shifting property will give us? Shifting property will give, suppose if you have a function f of x and the Laplace transformation of f of x will give us f of s, then we will get such that Laplace transformation of e to the power a of x, f of x, this will give us Laplace transformation of s minus a. Yeah, this is very much important property of shifting property of Laplace transformation. Means if Laplace transformation of f of x will give us f of s, so Laplace transformation of e to the power ax f of x will give us Laplace transformation of f of s minus a. Similarly, here if we are putting here minus Laplace transformation of e to the power minus a of x f of x, then we will get f of s plus a. Let us take an example. Suppose Laplace transformation of e to the power ax f of x, we will get f of s minus a, or Laplace transformation of e to the power 0x f of x, means f of s minus 0, means Laplace transformation of f of x, we are getting f of s. That's proved. Another important property of the Laplace transformation is scaling property. Scaling property. So scaling property of the Laplace transformation is such that Laplace transformation of f of x is f of s. So if f of x is scaled as f of ax, f of ax is scaled to f of ax, then what we will get? Laplace transformation of f of ax, we will get 1 by a, let me write clearly, 1 by a f of s by a. So similarly, Laplace transformation of f of kx, it will give us 1 by k f of s by k. That's the important property. Another important property of the Laplace transformation is such that Laplace transformation of f of x divided by x, it will give us integration s to infinite f of s ds. So that's it. Similarly, let us do some examples or problems on based on this property, so it will be cleared more. Suppose you have to do Laplace transformation of e to the power bx cos ax. Now first doing this thing, before doing this thing, you first should remember that Laplace transformation of e to the power ax f of x is what? F of s minus a. So and the Laplace transformation of f of x is what here? F of x is cos of ax. So Laplace transformation of cos of ax will be what? Laplace transformation of cos of ax will be what? S by a square plus a square. Now Laplace transformation, it is fx, here it is fx. Now Laplace transformation of e to the power bx cos of ax, means shifting property we will use. So e to the power bx means s will be replaced by s minus b whole square plus a square. So Laplace transformation of e to the power bx cos ax will be, let me write clearly, Laplace transformation of e to the power bx cos ax, it will be s minus b divided by s minus b whole square plus a square. S by a square plus a square, that was the Laplace transformation of cos of ax. Now e to the power bx, these will be scaled, here b will be scaled, s will be replaced by s minus b, here in the denominator also s will be replaced by s minus b. That's it. Similarly, let's discuss the Laplace transformation of x to the power, another important property, Laplace transformation of x to the power n f of x. Laplace transformation of x to the power n f of x will be minus 1 whole to the power n ddn d of xn f of s. Yeah, that means what? if we are doing the Laplace transformation of x to the power n f of x, we will get minus 1 whole to the power n ddn d of x whole to the dx of whole to the power n f of s. So let's try an example to clear this topic, to clear this property. Suppose we have Laplace transformation of x sine ax. That means similar form as Laplace transformation of x of a f of x. Now Laplace transformation of sine ax will be what? A by a square plus, let me write clearly, a by a square plus a square. Yeah. And x to the power n f of x. Here n equals what? N equals 1. So Laplace transformation of x sine ax will be what? X f x equals what? X f x, Laplace transformation of x f x equals minus 1 whole to the power n ddn ds in f of s, that we got. So here n equals 1. So minus 1 whole to the power 1 dds, and here it will be a by a square plus a square. So we will get Laplace transformation of x sine ax will be, Laplace transformation of x sine ax will be minus 1 whole to the power 1 dds a by a square plus a square. Okay. So after solving it, we will get 2as divided by a square plus a square whole square. So these are how we will apply Laplace transformation of x to the power n f of x. Similar property is such that Laplace transformation of, let me write clearly, Laplace transformation of sin x by x, that is similar as Laplace transformation of f of x divided by x. Laplace transformation of f of x divided by x, what we are getting from it? We are getting that s to infinite, formula is s to infinite f of s ds. So here we can write Laplace transformation of f of x divided by x, where we have got that integration s to infinite f of s ds. Similarly, if instead of fx we are putting sin x. Okay. So Laplace transformation of sin x is what? Laplace transformation of sin x will be a by root of a by a square plus a square plus a square. A is what here? A equals 1. Here a is what? A is 1, because sin ax, instead of sin ax we are writing a equals 1 sin x only. So here Laplace transformation of sin x will be what? 1 by a square plus 1. Okay. So f of x by x, sin x by x will be what? Integration s to infinite ds by a square plus 1. Okay. So ds by a square plus 1, it will give us tan inverse s to infinite. So tan inverse infinite means pi by 2. Pi by 2 minus tan inverse s, what we are getting? Pi by 2 minus tan inverse s, cot inverse s. This is the Laplace transformation of sin x by x. This is the thing we are getting. We are getting that Laplace transformation of sin x by x. One of the most important property of the Laplace transformation is Laplace transformation of periodic function. Laplace transformation of periodic function. Periodic function means if a function is such that f of x plus nt equals f of x. That means the period is nt. If a function is such that f of x plus nt equals f of x, so that Laplace transformation of periodic function will be what? Laplace transformation of periodic function f of x will be 1 by 1 minus e to the power s of t integration 0 to t e to the power minus sx f of x dx. So this is the Laplace transformation of periodic function. That means If we have a period t of a function, then Laplace transformation of f of x will give us 1 by 1 minus e to the power s of t. T is the period, integration 0 to t, the time period, e to the power minus s of x, f of x dx. This is the Laplace transformation of periodic function. Let's take an example of this periodic function. Let's do an example. Suppose we have a function f of x equals x square. Okay. Within range 0 less than x less than 2. And suppose f of x plus 2 equals f of x. That means period is what here? Period is here 2. So Laplace transformation of x square will be what? Laplace transformation of x square will be what? Here 1 by 1 minus e to the power minus 2s integration 0 to 2, that period, e to the power minus sx x square dx. So after doing the integration by parts, we will get the result. This is how we can do the Laplace transformation of periodic function. So that's where some important properties of Laplace transformation that we should know. So there are some more important problems of Laplace transformation. That another important property of So now one of the most important property we will study, that is the Laplace transformation of derivative. Laplace transformation of f of nx in nth order derivative. How can we do that? The formula for Laplace transformation of f of nx is that s to the power n f of s minus s to the power n minus 1, n is reduced to n minus 1, f of x at x equals 0, minus s to the power n minus 2, f dash x. Now the power of f is increasing, f dash x equals 0, dot dot dot. At last we will get the series as, again writing here clearly. This is very much important. You all should know that I am writing clearly. Laplace transformation of nth order derivative of x, we will get s to the power n f of s minus s to the power n minus 1 f of x equals 0. Here n is reducing, power reducing, minus s to the power n minus 2 f prime x equals 0, minus dot dot dot. At last term s to the power 1, here s to the power 1 or s, you can write only s at last of the series, s to the power s f of n minus 2 at x equals 0, minus s to the power 0 means no s, then it will be only f of n minus 1 at x equals 0. So let's discuss this property actually. So Laplace transformation of nth order derivative will be what? Here Laplace transformation of nth order derivative f of nx we are writing. So nth order derivative s to the power n, here s, the power of s to the power n is here, power of s is n, and power of n fx is Laplace transformed Laplace transform function, sorry. Now n is reducing s to the power n minus 1, and instead of fs we are writing f of x, that means main function at x equals 0. Okay, now n minus 1, again it is reducing s to the power n minus 2, but now the derivative of f of x is increasing, f dash x equals 0. Now secondly will be s to the power n minus 3, and it will be f double dash at x equals 0. In such a way, after doing at last of the series, we will get s to the power 1 f of n minus 2 at x equals 0, f to the power minus f to the power n minus 1 at x equals 0. So suppose let's take an example, Laplace transformation of second order derivative. Let me change the pen color. Laplace transformation of second order derivative f double prime x will be the s to the power n f of s, means here firstly will be a square f of s, now 2 will be reduced, 2 power will be reduced, s to the power 1 f of x equals 0. Okay, now 1 will be reduced, s to the power 0 f prime x equals 0. So we will get what? We will get a squared f of s. F of s means Laplace transformed function of f of x minus s f of x equals 0 minus f dash x equals 0. Similarly, Laplace transformation of first order derivative of x, Laplace transformation of first order derivative of x, that is n equals 1, that means s to the power 1, s to the power n f of x, means s to the power 1 f of s minus s to the power 0 f of x equals 0, that means we will get s f s minus f x equals 0. So that is the Laplace transformation of the derivative of that function. So this is the most important thing of the Laplace transformation. So let you clear. Similarly, if you can write the Laplace transformation of n equals 3, means third order derivative f3 Laplace transformation, what you will get? S cube f of s. Now cube will be reduced, s square f at x equals 0 minus s f prime x equals 0 minus s to the power 0, s to the power 0. Then what we will get? Minus s to the power 0, that will be f double dash at x equals 0. In such a way, we are getting the Laplace transformation of the derivative. Another important property of the Laplace transformation, that is limit x tends to 0 f of x, it will be limit s tends to infinite s f s. Limit x tends to 0 f of x or limit x s tends to limit x tends to 0 f of x equals limit s tends to infinite s of f s, or limit x tends to infinite f of x equals limit s tends to 0 s f s. So that is it for today. That is actually some important properties and some important things about the Laplace. Thank you for patiently watching my video. That's it for today. Thank you all for patiently watching my video. Bye.